Okay, I've been thinking to myself like there will be a day when this date will be quite old, 30th October 2021. It will be history. I wanted to come up with questions on pressure and flotation, but I realized I was just making questions concerning flotation. So pressure, we'll take a look at that one later on, involving the barometer, the manometer, and stuff like that. So I think 4 questions. Let's just get down to business. A cuboid, this is cuboid, of mass 450 grams floats in water as shown below. If the edge of the cuboid, not cube. I was just making this from my mind, but I know too they have an objective. Is 10 centimeters and its length is 14 centimeters, and width 8 centimeters. Therefore, this is my 8 centimeters here on the box, the width. Cuboid water, yeah, figure 1.1, So A, calculate the volume of water displaced if the cube is only sunken 3/4 of its width. What's our width? Width is 8 centimeters. 3/4 of its width is the portion sunken. So I'll maybe directly go to the solution here. For A, I have to find the volume of the box that has been sunken. So I have to find 3/4 of this 8, which gives me 6. Then the other dimensions are, the same. So the volume of the cuboid sunken is 840 cubic centimeters. What's the question again? Calculate the volume. Yes. So what is the weight of the water displaced by the cuboid? The volume of the water sunken, the part of the box sunken is equal to the amount of water displaced. So B, the weight, remember, weight is equal to mg, okay? So here we're told that we take density of water, rho W of water is 1 gram per cubic centimeter, and gravity to be 10 newtons per kg. Look, there's gram here, there's gram there, then there's kilogram here. So you have to find a way of harmonizing gram and kilogram there. So I come here, I simply do my thing. Weight is equal to mass times gravity. Am I correct to say mass is 840? Okay, times 10. I think I'm correct because I've divided by 1000. Okay, so the mass of the displaced water is equal to its volume. When you look at this density here, density of water is 1 gram per 1 cubic centimeter. This is per centimeter cubic, so per 1 gram per 1 cubic centimeter, meaning 1 cubic centimeter has a mass of 1 gram. So if the amount of water displaced is 840 cubic centimeters, it means the mass of this water is actually 840 grams. So if I have to convert it to kgs, I have to divide it by 1000, because 1 kg is equal to 1000. If I have to convert the mass to kgs, I have to divide by 1000, because 1 kg is equal to 1000 grams. This is the 1000 here. Then the 10, that's our gravity. So it gives me 8.4 newtons is the weight of the water displaced. What is the weight of the water displaced by the cuboid? It's 8.4 newtons. My last question there, determine the buoyant force acting on the cuboid. The buoyant force sometimes is called the upthrust. So the upthrust is equal to what? It's equal to the weight of the water displaced, but you have to show some calculation. Okay, I think I'd even explained here on how I found my mass here. So that is density, that is rho times V, the volume is this, the density is that, it gives you this in kgs. Then as in kilograms, it's 0.84. So I could have put 0.84, but I didn't really put it there, but it's the same thing if you look harder. So the formula for buoyancy, of calculating the buoyant force or the upthrust, is volume times density of the liquid times gravitational constant. So this is volume converted to cubic meters, because the density is expressed here. I've expressed the density in kilograms per cubic meter. That's the density of water. I've done this because G is simply 10 newtons per kg, so this has to go to kgs and this has to go to cubic centimeters, because the kg goes with the cubic centimeters, and then the gram goes with the cubics. The kg goes to cubic meters. Look at this, density is in cubic meters, so even this volume should be in cubic meters, while the grams go with this. Okay, so finally when I do my algebra there, the buoyant force or the upthrust goes to 8.4 newtons, which is the same as this one here, but I had to show it. Okay, so I've written here buoyant force or upthrust is equal to the weight of displaced water or any other liquid if the object is sunken in another liquid. A 40-gram piece of metal was placed in a jar of ethanol. Now it's not water but ethanol. Ethanol has its own density, so when you're applying that formula, remember the density of ethanol. If the volume of the metal is 30 cubic centimeters and the density of ethanol is 0.98 grams per cubic centimeter, determine if the metal will sink or float. So you have to compare the two densities. Just calculate the density of the metal, and since you're given the density of the liquid here, note to say an object will only float if its density is less than the density of the fluid or liquid you have placed it in. So density of metal is rho is equals to m over v. Our mass here is given as 40, and then the volume is given as 30. So when you do your calculations, it comes out as 1.33 grams per cubic centimeter. This is greater than the ethanol, so metal sinks is our answer. So I just went further to just do one or two calculations to just worsen this, buoyant force. If we have to calculate for the buoyant force here or the upthrust on the metal as it sinks, because it won't sink as if it's falling in air, it will sink slowly. Have you ever wondered why it's hard to just walk properly in a swimming pool? Yeah, it's because of buoyancy. When you lift your leg, you cannot easily put it down because the water will still push you up. That is why it's easy again to lift someone in water. Their weight is reduced by the upthrust or buoyant force. So here, as the nail or the piece of metal will be sinking, calculate the amount of force that will cause its speed of sinking to be slow. Okay, if I was to write such a question. So just go for the weight of the displaced liquid, which will give you 0.294 newtons. Okay, 0.294 newtons. That would be the buoyant force. The next question there is two identical bodies are placed in water. If the total volume of displaced water is 70 cubic centimeters and the upthrust on body A is 50 newtons. 50 newtons. If they're identical, even this one is 50 newtons, calculate the volume of water displaced by B. The fact that they are identical, it means they're of the same volume. So you simply just divide this volume by 2, meaning the answer is this one. They're identical. Number B, calculate the mass of water displaced by B, given that G is equal to 10 newtons per kg. The mass is equal to the amount of the mass. Okay, let me not go that far, but the mass. Let's go to mass. We use the formula for weight. Weight is equal to mg, but make m the subject. The weight of the water displaced by B, which is identical to A, and we are told 50 newtons. I mean, not 50. And the upthrust on body A is 50 newtons. Okay, so the weight of the displaced water is equal to the upthrust. So meaning this is actually the weight of the displaced water. Okay, that's the weight of the displaced water. So this is our weight of displaced water over G, which comes to 5.0 kilograms. Okay, that would be the mass of the displaced water by B. So the key word here is identical. Identical. I get to my, I think, last question now. So a wooden block floats with a metal block attached to its bottom, as in the figure. Okay, that's a wood, steel, or metal. I think I should have said metal. Then in water or whatever this liquid is, given that the metal block is of mass 1.8 grams, kgs, I mean 1.8 kgs, and the volume is 125 cubic centimeters. Calculate the upthrust on the wooden block only if the total upthrust on both bodies is 1980 newtons. I think I made this number to be very big. After I did my calculations, I realized I should have just written 980. So calculate the upthrust on the wooden block only. Solution: the buoyant force on the object is equal to force on the wooden block plus force on the metal bar. It will give us the total buoyant force there because they are both experiencing upthrust. Buoyant force on water is equal to buoyant force on total on both objects minus buoyant force on metal bar. So finally, total buoyant force minus 1.25 newtons from the buoyant force on the metal bar gives me 1978.8 newtons will be the buoyant force on the water. So since in the question we've been told that the total force, have we been given the total force? Yes, it's here. And then we've been told that the metal bar is of volume this much and mass this much, meaning we can find the weight of the water this metal bar displaces. So weight is equals to mg. When I convert this weight, this mass, to kilograms, it gives me 0. This is the mass here. Okay, this is water. 1 gram is equal to 1 cubic centimeter. This is pure water. That's pure water. So if you're having 125 cubic centimeters of pure water, then you are having 125 grams of pure water. So I haven't really brought it out much as pure water, but this is how I'm bringing it out. So this is the mass of pure water in kilograms. Then G is a constant. Then this is the weight of the pure water. Okay, so mass is equal to density times volume. Density of water is 1 times volume is this. It comes out as this if you want to do your calculations, and then converting this to kilograms gives you this here. So I think, oh yeah, I've given the density of water is this, and then G is that. So from that you have to see it. So this is how I found the weight of the displaced water, which is equal to the buoyant force on that object which has displaced, on that object whose volume is this, which is our steel object. So this is how I did my subtraction, and the buoyant force on the plank is greater. That is why this steel bar, if in as much as it has got some buoyant force from the water, is not able to pull the wooden block down with it. I end here, and hopefully this was helpful in one or another. See you in the next videos. Bye bye for now.